Hello everyone. In this video, we are going to see how to design a microstrip patch antenna using HFSS. So let's start. First of all, open your HFSS tool. It will be a blank page at first when you open it. So you'll have to insert the HFSS design. For that, go to Project, click on Insert HFSS Design. See the coordinate system and you will get all these options. As we are going to design a microstrip patch antenna, it consists of three most important parts. Those are substrate, patch and the ground plane. First we are going to design ground plane. For that, click on rectangle. Now, as you can see rectangle, create rectangle, we have got this options. Why did I choose this rectangle shape? Why not box? Because ground plane will have two dimensions, that is length and breadth. So I have chosen 2D rectangle. Okay. Now go to create rectangle. Here you can give position values. I am giving all zeros. And X size. X size means nothing but width of the rectangle, which you can calculate using the formulae. I mean design equations. There are design equations which are available for designing an antenna. I have calculated the dimensions of the antenna using them. So here X size means, I have already told you, X size means width, which is 6.1686 for me. And remember, all the dimensions must be in mm, that is millimeters. Y size is length always. Remember this point, X width. X represents width and Y represents length and Z represents height. Click on OK. See, now you have given the dimensions. So click on this full view option to see like this. Okay. And now we are going to name this rectangle. It is actually ground plane there, right? Name it as ground plane. Ground plane. Okay. Okay. See, it is unassigned, right? So you need to assign for it. For that, click on rectangle, right click. Go to assign boundary and then perfectly. Why perfectly? Because it is not a dielectric material, it is a conductor, right? So we are giving perfectly. Now we are going to design the substrate. Substrate is a 3D element, right? So consider a box. Draw it anywhere. So this is my substrate. See, box, create box, those options have been created, right? Click on create box and give the values. 0, 0, 0, my position values. X size is width. And remember the most important point, the width and length dimensions of substrate and ground plane are always same except for the height, because it is 2D, this substrate is 3D. See, I have given. Now click on OK. See, it has been created. Now click on box 1 to name it. I'm naming it as substrate. Okay, and my material is, for choosing the material, you have to click on edit. Now search for your material. My material is Rogers RT 5880 Duroid. Here it is. That's it. Choose a color, transparency, click on OK. Okay. See, I've got my substrate. Yeah. And now it's time for designing the patch, the radiating element, the most important element. Again, patch is a 2D element. So, take a rectangle. Now, click on this create rectangle. Give the position values for the patch. I've already calculated it. X is width, Y is length, click on OK. See, my patch is exactly in the middle, right? This is my patch. And now click on rectangle. Name it as patch. Patch. See, this is my patch. And now, as you can see, it is still unassigned as we didn't assign for it. So let's assign. For assigning, right click on patch. Assign boundary. You need to assign perfect E. You need to assign perfect E boundaries for both patch and the ground plane. Now it's done, right? It's time for us to create feed line. So for that, change this to ZX coordinate system. You need to change the coordinate system. And here we have an option to rotate our model. Using that, I'm rotating my model like this. Perfect. And now I'm going to choose a rectangle for feed line. Yeah. See, create rectangle, go to create rectangle, give position values. I have already calculated it. See, this axis must be Z, not Y. As I have told you, X represents width, Y represents length. It still doesn't change. Okay, no problem, you will get it. Actually, there are formulae available for calculating all this. It's available in Antina's textbook by Balanis. What happened? Okay. It is still... Oh. You see, 0.4 is my width and my length is 1.5137, length of the feed line. Now you have to give your dimensions for the feed line. For that, click on create rectangle, give position values, oh sorry, I forgot comma. You need to keep comma as it's a 3D point. Yeah, perfect. Now this is my width, 0.4. Comma 0, 0 point. This is my width, 0.4, and my length 1.5137. Click on OK. See, as you can see, I've got this error. Sorry, as you can see, the feed line is overlapped with the patch. For that, you need to unite them. As feed, my feed is microstrip line feeding technique. So, I have to unite this feed line with the radiating element patch. For that, click on this rectangle, press Ctrl and click on patch. Now you see some of the options are highlighted for me. Click on this unite option. They'll get united. See, they have united. Yes. See, here we have this unite also, under which we have this feed line and patch. I'm going to name it as feed line. Give color for it, and then transparency. Okay, yeah. As you can see, the feed line is also unassigned, so just assign for it. Perfect. Okay. I forgot to name my ground plane, so I'm naming it now. Ground plane. Okay, yeah. Now we are going to create another rectangle. I'll tell you why. Okay, so for that, choose a rectangle. Okay, go to create rectangle, give its values. See, I have created this rectangle to assign lumped port, because it is the way to give the feed. It is in direct contact, right? So for giving feed, you need this lumped port. See, it is in direct contact with the feed line, our feed line, right? So go to rectangle, name it as lumped port, or else shortly LP. Give it a color, and then transparency 0.6. Now you need to assign it. Before that, just zoom it. I'll tell you why. Okay, now right click on LP and go to assign excitation, lumped port. Select it, click on next. Go to integration line, none will be there. Click on it, click on new line. See, you need to draw a line like this. Did you see an arrow? You will get defined if it's correct. Now click on next. Finish. That's it. This has become our lumped port. Okay. Now this is my antenna. What's next? We have to create a radiation box. We need to create a radiation box. It's mandatory for us to analyze it in a perfect environment like air, free space, like that. If you want to analyze, you need to create a radiation box. Give x value, which is width, y value, which is length, z value, which is height, click on OK. See, now go to box 1, click on it and give it a light color so that you can see your patch, your antenna, and give high transparency like 0.8. Name it as radiation box. And the material should be air. For that, You know what to do, right? Search for air. I've got it. Most importantly, you need to click on this. See? I'm done. Oops, I've got some error. Let us check. Oh, radiation box. Perfect. Click on OK. Now, click on this box 1. Right click to assign boundary. Assign boundary. You need to assign radiation as it is a radiation box. Rad 1. Click on OK. Yeah. Now, you need to check for your validity. Click on tick option. See, you'll get a report like this where I've got this wrong mark on analysis setup since I haven't given any solution frequency. So for that, close it. First of all, close it. Did you see this project manager? Click on HFSS design. Expand this. Go to analysis. Right click. Add solution setup. Yeah. Give your solution frequency. As I have designed my antenna at higher frequency, I'm giving it 38. Number of passes must be greater than 10. So I'll give 20. Now click on OK. And go to analysis again. Setup, right click on setup to give frequency sweep. So go to option add frequency sweep, where you can select the start and stop frequencies. You can give the step size too. Click on display once you check whether it's correct or not, and then OK. Now once again you check for the validity. Go to tick mark. See, I've got all ticks, right? So close it. Now we are good to go. Good to analyze all. So click on the button, click on the icon which is next to tick mark, that is analyze all. Click on it. For that, you need to save your project. I'm saving it as project 1. Click on save. As you can see, it is buffering, right? It is analyzing. It will take some time to analyze it. To analyze the antenna. See, I have got it. Solution setup, sweep, and then next to it, normal completion of simulation. It says that your antenna is simulated perfectly. Now you have to generate the plots, which is the most important thing. For that, go to results, right click on it, create model solution data report, click on it, and then rectangular plot. Now I'm going to generate return loss plot. For that, you need to select this S parameter, S11, and then dB. Now, new report. See, this is my return loss plot. Likewise, you need to generate some more plots. For that, you need to click on radiation, right click, insert far field setup, and then infinite sphere. Change this theta value, stop value to 360. For generating 3D plots, you need this. So, now go to results, right click, create far field reports, 3D polar plot. Gain total, dB, select dB again. New report. See, I've got my gain. Go to results, create far field report, 3D polar plot, directivity. Now select directivity in category, DIR total, and then dB. Function is dB. Generate new report. That's it. You'll get your directivity report. Now go to results, again create far field, select radiation pattern, RE total, dB. That's it, new report. This is my radiation pattern. Now go to results, create model solution data report, rectangular plot, select VSWR, new report. Yeah. So that's it. This is the way to generate reports. Thank you all for watching this video. Please subscribe.